In this experiment, we will familiarize ourselves with different latches and flip-flops. First, we will check the working of an SR flip-flop using NAND gates. There are three inputs: enable, E, set, S, reset, R, and two outputs, Q and the complement of Q. When the enable is 0, the outputs will remain the same in respect of the outputs. When enable is 1 and S equals 0, R equals 1, the output will reset. That is, the output will be 0. When enable is 1 and S equals 0, R equals 0, the output will remain in the previous state. When enable is 1 and S equals 1, R equals 0, the latch will set the output to 1. When enable is 1 and S equals 1, R equals 1, the output and the complement will give 1, which is the invalid condition. D-latch is a modified version of the SR flip-flop. Here, when E equals 0, the output will not change with D. When E equals 1, the output will depend on D input. If D equals 0, output will be 0, and if D equals 1, output will become 1. Next, we will study the working of a JK flip-flop. It consists of J and K inputs, preset and clear inputs, and a clock input. When preset equals 1 and clear equals 0, the flip-flop will reset the output to 0. And when the preset equals 0 and clear equals 1, the flip-flop initializes the output to 1. For normal operation, both preset and clear are connected to VCC. It could be noted that the flip-flop we are using here is a 74 LS109, which is a positive edge trigger flip-flop. Since the input of the flip-flop is K, the K input should be connected through an inverter. When J equals 0, K equals 0, then during the positive edge of the clock, no change in the output will happen. When J equals 0, K equals 1, the output will change to 0. When J equals 1, K equals 0, the output will change back to 0. When J equals K equals 1, during each positive edge of the clock, the output will toggle. Now, we will check the D flip-flop IC 74LS74. Similar to JK flip-flop, this also is having a preset and clear inputs and a clock. When preset equals 1 and clear equals 0, the flip-flop will reset the output to 0. And when preset equals 0 and clear equals 1, the flip-flop initializes the output to 1. For normal operation, both preset and clear are connected to VCC. Now, making D equal 1, and when the clock is applied, the output changes to 1. When D equals 0 and the clock is applied, the output changes back to 0. Next, we will see how to design a JK flip-flop using D flip-flop ICs. For normal operation, we will set the preset and clear to 1. For J equals K equals 0, the output will remain in the previous state. When J equals 0, K equals 1, the output will change to 0. When J equals 1, K equals 0, the output will change back to 0. When J equals K equals 1, during each positive edge of the clock, the output will toggle. Now we will check how to design a T flip-flop using JK flip-flop. Here we will make J equal K equal T. For normal operation, we will set the preset and clear to 1. When T equals 0, the output will remain in the previous state. When T equals 1, the output toggles. For designing D flip-flops using JK flip-flops, we will connect D directly to the J and D will connect to the K inputs. For normal operation, we will set the preset and clear to 1. When D equals 0 and the clock is applied, then the output will become 0. When D equals 1 and the clock is given, the output changes to 1. We implemented the SR latch with enable here. Switch 0 is the enable input, S is connected to switch 7, and R is connected to switch 6. The Q output is at indicator 7 and Q bar output is at indicator 4. When enable is 0, the changes in the output will not make any change in the input. When S equals R equals 0, the output will remain in the previous state. If S equals 1, R equals 0, then the output Q will become 1. Again, go back to S equals R equals 0, the output will not change. Now, when S equals 0, R equals 1, the output Q will become 0, and Q bar will become 0. Again, inputs 0, 0 will not change the outputs. When S equals R equals 1, the outputs Q and Q bar will become 1. This is an invalid condition. Next, we will check the working of the D flip-flop. Here, switch 7 is the preset and switch 6 is the clear. Switch 0 is the D input and switch 3 is the clock signal. Here, we are only checking the Q output. I will initialize the output to 0 by setting clear equals 0 and preset equals 1. Then I will make both preset and clear to 1. If I want to initialize the output to 1, I will make preset equals 0, clear equal 1. Then change the preset equal clear equal 1 for normal operation. Now we will make D equals 0 and apply the clock. The output will change to 0. If I make D equal 1 and apply the clock, the output will become 0.